We are finishing off chapter 5 here with something that will make all of your system of equations a little much easier to solve. So learning target 11, we'll just do a little bit of finding inverses of matrices manually, which won't be all that much fun. But then learning target number 12, got to change that, is use inverse matrices to solve systems of equations, and we're going to be using our graphing calculators to be able to do this. And so it'll be hard to do on here, but you will have seen in class just exactly how to set that up, and we'll try to give you some instructions here online to be able to do that. All right, so what are the big things today? Well, first thing, we've already talked about this, but an identity matrix. So an identity matrix, you would multiply by, and you would get the original matrix. And we know now how to multiply matrices. So like a 2 by 2 matrix would be, the identity matrix would be like this. And this pattern would continue if I had a larger one, like a 3 by 3. And so this is the identity matrix, or examples of identity matrices. Okay, here's what I want you to know about the inverse matrix. Well, primarily, here's what's going to happen. An inverse matrix times the original matrix. So we use this symbol, that right there, although this is not the same as 1 over A. Like it might be with numbers. With matrices, it just means inverse matrix, which is not the same as that, would equal the identity matrix. So just like if we had 2/5, we could multiply by the inverse of 2/5, which would be 5/2, and we would get the multiplicative identity, 1. Well, here if we have a matrix and I multiply by the inverse matrix, then I would get the identity matrix. And so this property is going to help us very much with solving systems of equations. All right, so here's the process for manually finding an inverse of a matrix. So we're going to let you mostly use your calculator for the rest of this, but in order to justify using your calculator, I'm going to make you manually kind of show how to find an inverse. So here's what we're going to do. We're going to basically take this, and we're going to, so 1, 0, 1, 2, negative 1, 3, 0, 0. And then we're going to tag on the identity matrix over here. Oops. Sorry, that should be 0, 1, 0. And then 0, 0, 1. Okay, so what we're going to do is essentially we're going to take our original matrix, we're going to do our row transformation stuff that we did earlier this year to turn this into the identity matrix. And so it's very much like what we did earlier with the row reduced echelon form. And then as we convert this to the identity matrix over here will turn into our inverse. And so first things first, how could I turn this into the identity matrix? Well, I've already got a 1 here, so now I want to turn these into zeros. And so I'm going to go ahead and multiply row 1 by -2. So -2 times row 1, and then add that to row 2. And when I do that, well, the top row is going to stay the same, 1, 0, 0. But -2 times 1 is -2. -2 plus 0 is 0. And we'll just kind of quickly go through here. So 0 minus 2 would still be -2. And then I've got the 1 here, so -2 times 1 is -2. -2 minus 1 is -3. But we also have to go all the way through here. And so when I do this, I wind up with -2, 1, and 0. And then, of course, the bottom row stays the same. Okay, so I've got a 0 in that spot. I'm one step closer to the identity matrix. Now I got to do the same thing to get rid of the 3. So I'm going to multiply the top row by -3, and then add that to row 3. And when I do this, I'll try to squeeze it in here. Okay, the top row stays the same, and the second row will now stay the same. And then the third row, well, -3 times 1 is -3 plus 3 is 0. That was the intent. The 0 is going to keep that the same. And then -3 times 1 would be -3. And then plus 0 would be -3. Of course, we have to do all that stuff over here. So I got -3 times 1 is -3. Plus 0 would be -3, just like before. The 0 up here will make that go away, plus the 0 is 0, and then the 0 plus the 1 would give me 1. All right, so I've got the first column into identity matrix form. I've got a 0 up here, so that's good. I need to turn this into a +1. And so I would just multiply everything through here by -1/2. And when I do that, when I multiply everything in the second row by -1/2, and again, the top row will stay the same, and the bottom row will stay the same. Okay, but the middle row, when I multiply everything through here by -1/2, well, I get 0. This, of course, turns into 1, which is nice. And then the fractions hit. So -1/2 times -3 would be +3/2. And then -1/2 times -2, well, that would actually just be 1. However, the 1 up over here times -1/2 would turn into -1/2, and the 0 would be 0. Okay, so again, we're getting ever closer. The rest of this is actually all still 0, so we've got 2 columns now that are finished. Now we have to fix the last one. And so we're going to need to turn this little guy, this -3, into +1. So I multiply this by -1/3. -1/3 times +1/3 will be 1. And that is going to turn this into 1. So I get 1, 0, 1, 1, 0, 0. The middle row stays the same. 0, 1, 3/2, 1, -1/2, 0. And then got 0, 0, -1/3 times -3 is +1, which is great. That would also turn this into +1. That would be 0, but this winds up being -1/3. All right, so we only have these 2 little sections left to go. And I need to turn this 3/2 into 0. So I've got the 1 here that I want to work with, so I'm going to multiply this by -3/2. -3/2 times 1 will give me -3/2, plus the 3/2 would make 0. So times row 3 plus row 2. All right, and as I go through this, again, top row will stay the same. Nothing's changed there. The bottom row will also stay the same. 0, 0, 1, 1, 0, -1/3. But now the middle row, well, the 0 and the 1, those are going to stay the same. This will turn into 0, as indicated. But now we got this other stuff over here. So -3/2 times 1, -3/2 plus 1 is going to wind up being -1/2. And then this one, -3/2 times 0 plus -1/2, also -1/2. And then over here, -1/3 times -3/2, and then add that to the 0, winds up giving us a +1/2. Okay, so we just have one more left to go. We need to turn this into a 0, and then whatever's left over here is going to be my inverse matrix. So in order to do that, I'm going to just take row 3, or I guess negative 1 times row 3, add that to row 1, and, well, let's see, the bottom 2 rows will mercifully stay the same, 0, 1, 0, negative 1 half, negative 1 half, positive 1 half, and then 1, 0, negative 1 third, 0, 0, 1. All right, so here we go. The 1 and the 0 will stay the same by design. We know that this 1 here will turn into 0, negative, I guess, negative 1 times 1 is negative 1, plus 1 is 0. But then we essentially have the same thing here. This will also turn into a 0, and times 0 plus 0 is 0. And then here I have negative 1 times negative 1 third. Well, that would be positive 1 third plus the 0 is positive 1 third here. All right, so we have turned the left side into the identity matrix. Whatever we now have on the right is going to be my inverse matrix. And so the inverse matrix of this guy is 0, 0, 1 third, negative 1 half, negative 1 half, positive 1 half, and then we've got 1, 0, negative 1 third. All right, so that by far is the most difficult thing you're going to have to do today, but it's essentially exactly the same as what we did earlier in this unit. All right, so now the question is, how can we solve a system using inverse matrices? Well, the whole thing is going to kind of stem from the fact that I can write this stuff as an augmented matrix. We'll call that matrix A. Okay, matrix A would be the 2, negative 3, 1, 5, the coefficients. We're going to call matrix X the X and the Y. That are represented here. And then we're going to say that B is my solutions over here, the 4 and the 2. So all I would need to do at this point, if I had A times X equals B, which is essentially what this represents, well, all I would need to do is take the inverse matrix of the left side. Of course, what I do to one side, I have to do to the other side. And, well, these two things multiplied together are going to be the identity matrix. We have seen that multiplying by the identity matrix is just going to keep it the same. So my x, which represents my answers, x, y over here, is simply going to be the inverse matrix times b. And, well, all that means in the context of this situation is I need to plug in this on my calculator, find the inverse matrix, which is pretty easy to do, and multiply that by this. So again, you'll have seen in class, I'm sure you can find a YouTube video that'll have it on there. But here's the steps for using your graphing calculator to work with matrices. You're going to go the second feature, and then matrix, which is about 3 buttons down. So second matrix. And when you do that, you'll see names, math, and edit across the top. You want to slide over to edit. And you'll see a list of possible matrices. So just click on matrix A. And you'll see a matrix there. It may or may not be the 2 by 2 that you want. So turn that into a 2 by 2 matrix and then fill everything in. Make sure you press enter after every single one, especially the last one. Sometimes that will get tricky. And then go ahead and do the same thing. Kind of start over the process, second matrix, edit, and then go ahead and put in matrix B. So again, make that a 2 by 1 in this case. And the 2 by 1 matrix is going to be 4 and 2. All right, and then quit out of that. So second quit. And then just go back to matrix, and instead of going over to edit, just click, so second matrix, and then just click enter to get the 2x2 matrix on your main screen. And then the inverse key is right there with the matrix. Just don't press second. So just do matrix A. So on your calculator, you would see something like this. And then click the inverse key, which is this one right here. And so then you would get a to the -1, then times, go back to second matrix, click on B. So you should have something that looks like this. And then press enter. And you get your answer. And our answer in this case is 2, 0. And that's solving that system using matrices. Now, if you're pretty good at using substitution and elimination, even this might not be faster. But I'm willing to bet that with a 3x3 matrix, this would be considerably faster and be a great way to check your work. All right, the only thing here is you have to remember that if you don't have a variable, you need to insert a 0 there. So this is like saying x plus 0y plus 1z equals -1. So my A matrix is going to be 1, 0, 1, and then 2, -2, -1, and then 3x, but I have 0y, 0z, okay? And then my x term, or my x matrix, is, again, just going to be x, y, z. And then my B matrix is going to be -1, 5, and 6. And so I'm going to go through the same process here on my calculator, putting this in for A. It's a 3x3 now. Putting that in, now it's a 3x1. I do the inverse of A, I multiply it by B, and you should wind up with your answer 2, 1, -3. And that is going to be way faster than maybe doing it out by hand. All right, that's it for chapter 5.